In this video, I'm going to continue on part 2 of the 2015 HSC. Now, I didn't quite finish talking about question 20. The answer is A, and the idea is if we look at this shear force diagram, we can see the 5 kilonewtons going up. We can see 1 kilonewton going down spread over 2 meters because it's a uniformly distributed load. We can see the 3 kilonewton drop, and then again, the uniformly distributed load as small amounts of shear force are dropping the diagram down. We see a sudden 7 kilonewton drop. We keep going down, and then we see returning back up for nearly 9 kilonewtons at the other end. So none of those other answers are correct in any way. They're just lines. Okay, so going on to question 21. The question asks us to explain. The key word is explain. When we see the word explain, we want to remember that we're talking about cause and effect. That's part of what we're talking about. Explain is often 3 marks, especially if we're asking to explain two things. So, what are some examples of things that we could talk about? Well, one of them is we could talk about airbags. That's a fairly obvious advantage. So we could say that airbags have resulted in fewer deaths due to as they cushion they cushion the deceleration in the event of a crash. It's not the most eloquent me retelling, but that's what I'd write. Airbags save lives as they cushion the deceleration in the event of a car accident.
That wasn't in older car models.
Airbags were not in older car models. Exactly right. Now, another thing that we could talk about, seatbelts, again, have a very similar purpose, that they prevent the sudden deceleration impacts within a collision. Other important things are collapsible steering columns. I think that collapsible steering columns have saved more lives than both the steering bag. No, it's just that people used to get impaled by the steering wheel. So now the steering wheel collapses. I heard about that in the podcast, The Nut Behind the Wheel on 99% Invisible. It's a podcast I strongly recommend. Another one that we could talk about is disc brakes. So disc brakes have improved the rate of stopping, or they've reduced stopping distances and resulted in fewer impacts, fewer collisions, because cars are able to stop more reliably. So disc brakes a benefit of disc brakes is that they have prevented accidents by increasing stopping force, reducing stopping distance, reducing stopping time. So by or cause, because they're words that you want to look at. Excellent. Okay, yep. So the windows, we've improved glass. So we have laminated glass on the steering wheel. So when you hit a kangaroo, you don't get hit with large shards of glass, which cause lacerations, puncture organs. And toughened glass on the side windows, which again have that same effect. But the toughened glass, you can access the car during an emergency. So if you're trapped in the vehicle in a fire, for instance, you can smash it and get out. Okay. Another good question I like is a hydraulic system. What's its advantages over mechanical systems? Well, first of all, we have a brake cylinder, which gives us a mechanical advantage thanks to Pascal's principle. That's one advantage. Another advantage is that they're more reliable. They have fewer moving parts, so they're less prone to mechanical problems or error or complications. Okay, I'll let Sergey with the answers tell me if there's anything else. But in the meantime, what I'll talk about is brake-by-wire, I think, is a really important question. So brake-by-wire is an advance beyond the hydraulic braking systems, and that's where we use computer technology, and computer technology is even more reliable. Again, there's a 99% Invisible episode about automation and talking about the pros and cons of automation, both with brake-by-wire and fly-by-wire. But for the moment, I'll just say it's more reliable, it has faster stopping times, but it also has its own complications, and it's not very popular with the public. Okay, so a couple of other points that students have just mentioned. So the fact that it's flexible is an advantage. It means that it's less likely to have problems. And reduced maintenance is another aspect. Okay, so moving along, and the advantage of mechanical advantage is it requires less braking force from the driver. So, okay. This question here is, again, this is the application of Pascal's principle. So we have 2 cylinders. We have a cylinder here. Cylinder A is 100 millimeters in diameter. Cylinder B is 700 millimeters. Oh, not in diameter. It's areas. which is great. Often we have to take the diameter and convert diameters to areas, but not this time. This time around we've got areas. So what is the area ratio between these two things? Yeah, 7 to 1 or 1 to 7. So that means that for every newton we apply on the x, we're going to get 7 newtons out of y. So if we get 50 newtons and we multiply by 7, it's going to be 350.
You can also do F equals F over A is equal to F over A for each distance.
Absolutely. Now, if you wanted to, rather than using the the velocity ratio by using the area ratio is equal to velocity ratio, you could also do the calculation by saying that stress or pressure in this case is equal to force over area. The two pressures, the pressure in vat A is equal to the pressure in vat B. That's the definition of Pascal's principle, is that linked containers will have the same pressure. And once you have that formula, you can rearrange the equation that way. Okay, now in this case here, when it talks about if rod X moves 60 millimeters, well, the same as a velocity ratio. If our velocity ratio is 7, so if it's moving down 60, the other one will move 6 divided by 7 is 11, 12, something like that. I'm not going to work it out, but
It's the ratio of distance area is 1 to 7.
Mm-hmm.
It's area times distance is equal to area times distance. And
Yep.
the resulting answer is 8.57 millimeters.
8.75 millimeters. Sorry about that. 60 divided by 7 is 8.7. Okay, question 22. We've got a radio receiver. Now, we have discussed radio receivers at this point already, but they've asked us to identify two parts. We have a diode and we have a capacitor. So A is the diode, B is the capacitor. What do these things do generally, and what is their purpose in this circuit? So diodes only allow the flow of electrons in one direction. They're made of two layers of semiconducting silicon with doping to only allow electrons to flow in one direction. What is the purpose? And capacitors build up charge, so they store up the number of coulombs of charge, or basically hold back electrons until the charge is sufficiently great that it continues to flow. What is the purpose in this diagram is that the diode creates a half-wave rectification, and the capacitor provides where capacitors can provide smoothing of signal. In this case, what they do is this will filter out the carrier signal. So this is how we remove by dividing we're minusing the opposite side of the wave. So where originally we added the two waves together in an AM circuit, what we're doing here is we're minusing that wave, and all we're going to be left with is our signal, the message.
We add the opposite wave.
Exactly.
Completely out of phase, so it's
Yes. Yeah, we add the wave completely out of phase, or it is a good way of putting it. Okay, how have semiconductors influenced the design of modern telecommunication products? Okay, this is a good question. I like this. So, semiconductors are used to make diodes, which we just spoke about. Diodes have an important role in LEDs, light emitting diodes. So that's screen use is drastically increased. Probably not the question where they're expecting us to go. They're probably going to want us to talk about transistors. Transistors have two roles. Transistors act as both switches and what's their second application? Amplifiers. Now we're going to focus on switches. That switches allow us to produce things like NAND gates, and from NAND gates we can program and we can have a variety of different computer circuits. So all of our modern smartphones, our telecommunication networks that connected to the internet, they all depend on transistors that we can use to program. Okay. Moving on to question 22. This is a drawing question, so really the best thing I can do is show you the answers. So I'm going to try, there we go. Now, the point that I think is worth focusing on here is you'll notice that this drawing has been freehand drawn. And that is because you are allowed to freehand draw as long as you're within about a millimeter or two of accuracy. So a lot of the time I would say use a ruler if you can. It doesn't take much longer to use a ruler. Now, I've shown you a method of getting these lines equally spaced when we're using, when we're sectioning. Now, some other things that are worthwhile, now these are close enough to being equally spaced. Personally, I would like you to use a ruler when you're sectioning. But more important than that, here are the big things that you'll lose marks for. Not including a center line will lose you marks. Not using different thicknesses of lines. So we can see that this line, the marker can determine that this line is darker than these lines. These lines are lighter. So that the section line and our center lines, that they are lighter. Hidden detail should be thick and dark, but all the others should be thin and dark. We don't section through nuts. We don't section through sleeves. We don't section through washers. And we can see a small amount of thread there and there. So that's what we're looking for to get those marks. How many marks was it? 6. Okay, so 6, it's a lot for 6. So when you consider that you'll lose a mark just for not having a center line, not for having the right sectioning. Oh, because there's 2 different materials, it's important that we section in opposite directions so that we can tell that this hatching is separate to that hatching. So let's say it's 1 mark, 2 marks, 3 marks, 4 marks, 5 marks for getting the hex nut lines in the right spot, and then the 6th mark would be just general overall shape for me. That's what I'd be looking at. So if you made, let's say you drew this too thick, or this too wide, or this too long, something like that. This shape here is a little bit interesting. You'll notice as well, there's even a little weld here that's just drawn through dark lines. But, okay, we'll go back to the diagram. Okay, a charger is shown. What are 2 properties that would be relevant when selecting material for the pins? Okay, so pins, they need to be strong and durable. Right, so steel is strong and durable. They need to be good conductors of electricity. Excluding conductivity. Okay, so we need strength so that it doesn't snap. We need something that's durability. I would also say we probably want something ideally that's corrosion resistant. That would be another point another property I would talk about. Hardness so that it doesn't wear away. Yeah, so that it doesn't, it's quite possible that if you used a soft material that eventually, if it's being pulled in and out of the wall socket over time, we don't want that thing to wear away. So,
Do you have heat resistance?
Yeah.
So it would melt at high voltages.
That's an interesting one. I would say thermal properties are important, so that the thermal properties that we don't, but it's a little bit of a touchy one, and it's hard to clearly articulate what you mean there and not say the opposite of what you mean. So that's where I would try and stay away from that. I would try and stick with your material properties. Okay. So that's what I would try and work with. So things like whether or not it needs to be hard or soft, whether or not it needs to be strong, whether or not it needs to be brittle, or whether it can afford to be brittle, or whether it needs to be... anyway, we can move on. Okay, it's covered in a polymer. What is a suitable manufacturing process? Injection molding. If in doubt, if we're talking about polymers, injection molding is really the... except for bottles, we go with blow molding. There is vacuum forming, but we don't tend to talk about that one as often. Okay, how do you describe injection molding? Okay, so I have given you a description that I put on Facebook way back when, but let's say the start of the process, we have granulated feed is inserted into the hopper. That's pushed through a screw, which builds up heat and pressure through the screw which builds up at the nozzle. When there's sufficient melt in the screw, it's forced into a mold. The mold, the feed is then allowed to cool in the mold until it sets and hardens, and then it's removed from the mold, and it is the flash is cleaned off. Yeah, and the risers are cleaned off. Is that more or less what it says there?
It's much simpler. It says polymer is liquefied and pushed into the under heat pressure.
Great. Just to repeat for people who are listening to the recording, the answer in the exam says polymer is liquefied, it's forced under pressure into the mold, and allowed to cool. That's basically it. Yep. Okay. So, contrast the key features of fixed and mobile telephone systems. This is a tough general question for me. So if I'm going for 3 marks here, I would be looking at, okay, first of all, mobile signals are portable, so they can be used by emergency services and people who need to be contacted when away from their home or office. That would be me talking about the benefit of it. The difference is, well, they need to be sent over radio waves rather than through wired connections. They need to have telecommunication towers to broadcast those radio waves. They're less secure, so there's less privacy when using mobile phone networks. There's also concerns about the location of telecommunication towers. What did they say?